Hey, welcome back to ILR Performance. Later on today, I'm going to release the last assembly video in the Tecate rebuild series. And when I was finishing up that video, I realized that there's a kind of an important part about power valves that I didn't really have a chance to touch on while I was putting that motor together. Um, Kawasaki KIPS valves, which means Kawasaki Induction Power System, are different than most of the other variable exhaust valve systems because they utilize this type of what we refer to as a power valve. They rotate at certain RPMs that are controlled by a governor inside the case. Um, It's a ball and a spring arrangement centrifugal, and it rotates these and it opens and closes anywhere from 2 to 4 extra exhaust ports in the cylinder, depending on what the year and what the model was. The power valves were built for most of the motors over the years out of aluminum. There are a couple of motors there, power valves are made out of steel. The steel ones tend to hold up better over time just because they're stronger material, but there's definitely some downsides. The heavier mass takes more time to open and close. If they get stuck, they tend to do more damage inside the motor rather than failing at the aluminum power valve. So there's, like anything else, there's a lot of good and bad to it. Anyway, this is a pair of like rare as hen's teeth kind of power valve. These are two original, genuine Kawasaki power valves from a 1987 Tecate 4 that are not broken. And the not broken is the rare part. So you can see they're in pretty good shape. There is a little wear and tear on the teeth over here. Not too bad though. But the shaft isn't broken. There's no damage there. There is some wear down here on the bottom, but again, nothing concerning. This would actually be a good set of power valves to continue running if we didn't have better options. The majority of OEM power valves that I take out of Tecate 4s look like this, um, and legitimately look like this. There is a right-hand power valve that's typically intact. Um, Generally kind of dirty, and a little bit of gear wear, but not too bad. And then the left-hand power valve is almost always broken off right above the gear, and it is very common for the entire power valve to be missing. Um, what happens is this breaks. It's intended to break at that point, and we'll talk about that a little bit later in the video. But the valve breaks off, and people don't notice that the valve broke off. They ride it and they ride it and they ride it, and eventually that valve rattles around until it breaks into enough pieces that it goes out the exhaust pipe, and 9 times out of 10 it simply goes out the silencer, and it's gone. Uh, no harm, no foul, not a big deal. I do occasionally get a bike in that does, or a quad in that doesn't run very well, and I find the power valve stuck in the muffler and it's restricting the flow. But most of the time, what you end up with is the bottom half of the gear in the cylinder. No, no evidence of where the top went to, and you have a right hand gear or right hand power valve that's in pretty good shape. So, talking about breakage. Um, if you look, both of these power valves are made out of cast aluminum, which by its nature tends to be somewhat fragile in terms of it's not very flexible. If it flexes very far, it breaks. Castings are pretty good as far as wear properties. You can see the teeth on a cast gear tend to wear fairly well. Castings get a hard skin on them when they're curing, so until you wear through that skin, they tend to wear pretty well. So they are easily producible in large quantity. Doesn't take a ton of machine work. They hold up pretty well. But the flip side is Kawasaki intentionally left the distance between here and here, this shaft, small in diameter. The reason they did that is because when this area gets all coked up with carbon, you can see that there's a fair amount of buildup here. You can see the carbon inside of here. You can see some stuff over here. What happens is these things over time build up carbon, and you put them away for the winter. Come back in the springtime, you fire the bike up, put her on choke, give it a couple kicks, fire it up. The bike's a little bit loaded up. So you take the choke off, and the first inclination to most people is to just rev that thing up like a bitch and clean it out. The problem is that the power valve's closed and the power valve is stuck because all that oil that's been sitting in there and all that carbon has glued the power valve into the bore of the cylinder. Now, the governor is driven off the crankshaft. The crankshaft rotates the governor gear. There's a couple of ball bearings in there on a ramp. There's 4 ball bearings in there on a ramp, and they push against the spring, which pushes on a rack gear that causes this thing to rotate. When this can't rotate, something has to give. If the gears in the motor fail, then you have debris inside the bottom end of the motor. It's in the transmission and clutch side. It's not in the crankcase side. But you have debris in the bottom of the transmission, which is not ideal. So Kawasaki designed this so that if this gets stuck and somebody tries to rev the motor up, it will break right here at the weak point of the shaft. It's supposed to break here. When you see a gear that's broken off, if you catch it early enough, somebody who pays attention that brings it in and says, "Hey, fired up in the springtime, seemed to run okay. It just doesn't have the power it used to have. It's down on power." If they pay attention and you bring it in, and they bring it in, you pull it out, and what happens is this falls out of the bottom of the motor or out of the bottom of the cylinder when you take the top end off, and the upper part is stuck. I've even had to drill them and tap them and pull them out with a slide hammer. It all depends. Sometimes they're stuck in there really bad. Sometimes you just have to warm them up and they come out. But the bottom line is these were intended to fail. If they don't fail here, Kawasaki put a plastic drive gear on the power valve governor so that if these don't fail fast enough, for example, if they were frozen down here as well as up here, and this failure point didn't occur because everything was jammed, the plastic gear will break the teeth off of. It'll stop the governor gear from rotating. You'll have a couple of pieces of nylon in the bottom of the transmission, which the transmission can kind of regurgitate without really any issue. So they did intentionally design 2 failure points into the engine. But like I said earlier, most people don't notice, or they notice that it doesn't run quite right. They just don't think to stop and take it apart. So you end up with these broken power valves inside the motor. The right-hand power valve rarely breaks. Part of that is the design, and part of it is just the way the motor runs. The left-hand power valve is almost always broken. Like I said, those 2 power valves that I took out of a motor not all that long ago are very, very rare. It's not very often that you find a left-hand power valve that's in any usable shape. Kawasaki quit producing power valves many, many years ago. You can still buy this power valve. That is a brand new, genuine Kawasaki right-hand power valve. In the bag. Buy them all day long. There's plenty of those around. That's the right-hand valve. The left-hand valve hasn't been available for, I'm guessing, 15 plus years. There's plenty of people wishing they could find them, or there were for a long time, and it's not not easy to come by. Every once in a while you'll find one, but Kawasaki doesn't have any of them. So a few years back, Mike Chick from the southern Washington area was producing a certain amount of Kawasaki Tecate 3 and Tecate 4 parts, and he decided to have some power valves made. These are one of the last couple of pairs of Mike's power valves. Unfortunately, Mike is no longer around. Devastated that he's no longer around, but anyway, not going to go down that path. But so these are a pair of Mike's power valves. Mike had these CNC'd by a local shop. Spent a lot of time doing R&D, trying to get them all work, but these are power valves that are built out of billet 6061 T6 aluminum. They're very well machined. They have the gears machined into them. They're all machined out of a solid rod of aluminum. They're very high quality. The dimensions are well controlled. It is good hard material. 6061 is not as hard on the outside as a casting is originally, but it is the same hardness all the way through the material. Where a casting's harder on the outside and gets soft on the inside, these are uniform hardness all the way through, so the gears wear pretty uniformly. They were a duplicate of the factory power valve. They were pretty good duplication. A couple of minor things that Mike changed along the way, intentionally. Good power valve. One of the things that Mike did do is that the original power valves are 6 millimeters here and 6 millimeters here, but because they had a breakage point, Mike increased the diameter right here to 8 millimeters. So they drop into a factory cylinder, 6 millimeters here, 6 millimeters here. They're stronger here. You won't find one of these power valves that is broken right there. Mike's power valves don't break here because they are 2 millimeters and bigger in diameter, and they are a better material. They're not a casting that snaps. They are a billet material that would bend before it broke. The downside to Mike's power valves were, because it doesn't break here, it tears the teeth off the gear. That is not the fault of the power valve that Mike built. Mike built an awesome power valve. But when, like we talked earlier, when people don't warm the bikes up properly and the power valve is stuck, if that can't break here, the rack gear rips the teeth off down here, and you can see they're pretty small teeth. You know, it doesn't take a whole lot to rip those off. So I have seen a number of motors come back where the power valves are both intact, but somebody's ripped the teeth off the gear. Not Mike's fault. No way, shape, or form is that a design flaw, but something to keep in mind that Mike's power valves, if you have a set of them, I still have just a couple of pairs left and then I'll be out of them. But they're a good replacement. They're 1,000 times better than the factory power valves, but you still have the same issue. If the bike sits or it's had a lot of carbon buildup, you got to warm it up real good to let everything warm up and release the power valves before you rev it up. So when Mike was building power valves, we do a lot of motors. I did motors for Mike. Again, awesome guy, the best of the best. When Mike was building his power valves, there are a couple things that I've run into over the years that I wanted done. The cylinders, especially if a power valve gets broken and it rattled, this piece rattles around in here for a period of time. This point piece on the power valve is the bearing area or the pivot area for the top. And this area down here is the pivot area for the bushing in the bottom. From Kawasaki, this is 6mm, this is 6mm, and this is 6mm. When you look at Mike's production power valve, you have a 6mm, an 8mm, and a 6mm. Good drop-in replacement, no modifications necessary, stronger here. But these motors were built in 1986 to late 1987, early 1988. They're worn out. The cylinders are worn out, the bushings are worn out, they have a lot of time on them, and a lot of them weren't well cared for. I talked to Mike, and when Mike was doing a production run, I had Mike build a bunch of power valves for us that are 8mm here and 8mm up here. And the reason for that is when I get a cylinder that's worn out, that has a big wear area here in the top of the cylinder, or they have a bushing in the bottom that has been egg-shaped or worn out, I can put the bushing in the lathe and I can ream it out to 8mm and get a perfect bore back through the middle of it. And I built a jig that goes down in the cylinder so I can line bore a new 8mm hole and then finish ream that 8mm hole in the cylinder. So when I get a cylinder that has a lot of wear and tear in it, I can repair it simply by doing the machine work here and the machine work there. And then I get a gear that has, or I get a power valve that is a billet power valve. It drops right in because it's factory diameter here, but I've increased the diameter here, which is, basically I'm oversizing it to repair the wear and tear. And now I have a shaft here, a shaft here, and a shaft here that are all the same size. So this is the gear that we keep in stock. Like I said, I don't have all that many of them left. It's been a few years since Mike's been gone. And I keep these for any time that I run into a worn out cylinder that needs work. If I have to, eventually when I run out of these, I'll probably have to go back to the old way where I bored out the cylinder to 10mm. I put a bushing inside of the cylinder and then I rebored them out to 6mm here. I can do the same thing on the bottom. I can take the worn out bushings, I bore them out to 8 or 9mm. I push a bronze bushing in them and I put them back together. But these were built to be a repair power valve. They work excellent. Pretty cool. So fast forward another decade. These are a pair of power valves that are built by a guy in Lee's Summit, Missouri. His name's Joel Little. Joel is a hardcore Tecate guy. Someday I need to go see Joel. I've seen pictures of his shop and he puts my shop to shame. I've been working on Tecates for a long time, but I've got nowhere near the cool inventory that Joel has. Joel decided to produce power valves here a couple of years ago. I don't know, 3-4 years ago. Well, that's probably not right. I think Joel started on this project quite a few years before that and learned along the way how difficult it is to produce a product from the ground up that was better than the original product, took all the design considerations and production considerations into effect, and ended up with a product that was better in every aspect. If you look at Joel's power valves, I'm not sure, I haven't actually tested any of the material. I'm pretty sure these are both 61 T651 aluminum. They are billet round stock, or they're fabricated from billet round stock, that I'm sure of. They are a 6mm, a 6mm, and a 6mm. So they differ from Mike's because Joel did not upsize these to 8 millimeters. I think that was a good choice. Being billet aluminum, they're much less inclined to break. They will twist before they break. And conceivably, you could have a jam power valve and it would actually twist that shaft there and not break the shaft off. It would also not rip the teeth off of the gear because the parts will yield because they are malleable parts and not castings. And so, if there's a problem, there's not going to be a hard failure point like the factory power valves, and you're not going to rip the gears or the governor apart inside the case if the power valve jams. So, pretty awesome solution. One of the other things that Joel did was the original power valves have a couple of teeth machined down like this in order to set the timing to the rack gear. Mike's power valves have the correct relationship between the cutout and the gear. They time very well. However, they don't come with the indexing. I don't know how well you can see that, but you can see that two teeth right here machined shorter than the other two. And the same thing occurs on this gear where two teeth are shorter than the rest. Those are the timing marks for the rack gear. It's not terribly difficult to time them without those, but Joel put the effort into making sure that those notches or those teeth were machined down to allow them to utilize the timing gears or the timing marks in the factory rack. I bought a number of sets of these from Joel when he produced his production run. They are by far the best power valve that's out there. The dimensions of the parts are more stable and more accurate than any of the power valves that I've seen from any of the aftermarket manufacturers. The cutouts are more accurate than the factory ones or any of the aftermarket ones. The gear timing, whatever tooling they're using, is highly accurate. I'm not sure exactly how they're indexing those, but when I check them, they're generally within less than half a degree between the tooth timing and the face of the power valve. That's pretty good because most of the aftermarket billet power valves are 1.5 to 2 degrees variation between the gear and the valve opening. Um, uh, you know, it's a lot of technical stuff, but the bottom line is these are the best fitting, most accurate power valves you're going to get for Tecate 4. They sell for a fairly reasonable amount of money, in my opinion. They're about $250 for a pair of them. Joel keeps them. He's very good at shipping them out. If I don't know how many he has in stock at any time. We keep enough inventory that we can do 5 to 10 motors all the time. So I try and buy about 10 sets or more at a time from Joel, try and snag him, after he's done a run. But if you see a motor on YouTube or Facebook or anywhere else that we put together here at ILR Performance, unless the customer specifically asked us to put factory power valves back in it, every motor that comes out of here now has Joel Illes power valves. They're not going to make you, 5 bike lengths faster than anyone else. They're, they're just incredibly well made. The tolerances are very precise. All the parts are properly deburred. If you buy a pair of power valves from Joel Little, you'll be able to take them out of the bag. You'll be able to wipe them down clean, and you can put them in a motor. Every single manufacturer that I buy power valves from for any other motor, I have to go through and I deburr the gears, I deburr the openings, I make sure that there's no extra material all the way around. It's probably, half an hour to an hour of prep work before I put them in. If you buy them from Joel, they come out of the bag, they go in the motor, and they work. So pretty impressive. I know he put a lot of effort into it. It's not what he did. It's not his day job. It's kind of a labor of love kind of thing. But these are pretty awesome power valves. They work really good. So here's another twist. I am a very big proponent of coatings. This happens to be a pair of factory power valves, factory Kawasaki power valves, and they are coated with a ceramic magnesium polymer. It's mostly ceramic. It has magnesium to allow it to expand and contract at about the same rate as the aluminum. Ceramics, when you put them over materials like aluminum, magnesium, some of the other soft alloys, zinc, they don't tend to stay on very well because when the aluminum expands inside the ceramic, it cracks the ceramic and it fails. This particular coating is a combination. It's a polymer, and it's very shiny, and it's very smooth. But being a ceramic, it has really, really good wear properties. So we can take either a factory Kawasaki power valve or an aftermarket power valve, and we can coat it with this ceramic magnesium polymer, and we get a ceramic wear material on the gear, which means that we don't get the wear and tear in the gear that we get off of all the aluminum gears. In fact, this gear will wear out the steel rack gear before you wear through the coating. Not that that's a problem, because we're talking about 20 years worth of wear and tear before either one of those parts is going to fail. We also, when we're coating a factory part or an aftermarket part, we're building up the diameter here and here by about 10 thousandths of an inch because of the coating all the way around. So we can go back into the cylinder and do a ream to open up the pin bore at the top, and we can ream the bushing at the bottom so that we can take up for any wear that has occurred over the years. I've probably done 30 plus motors with factory Kawasaki gears that are done with this ceramic coating. I have never seen one of them come back broken. So they don't break, they don't wear out. So if you have factory gears that are prone to breakage, this particular gear breaks all the time, the ceramic coating, to the best of our knowledge, has eliminated the breakage in any motor that we've done it in. It's fairly reasonable. It's less than $100 to coat both of the valves. So it is an option. If you have a good set of valves, you definitely can make them long-term, much more reliable valves by doing that. When we get into the aftermarket power valves, you can see these are some of the ones I talked about earlier: 8 millimeter, 8 millimeter, 8 millimeter. I have these in, the 6, 8, 6 as well. And I just had a couple sets of Joel's power valves done as well. This is a molybdenum disulfide coating, better known as moly. It is a dry film lubricant. It has really good wear properties. Doesn't require any oil or anything to lubricate. It is a self-lubricating material, so that what's in the gears and what's on the shaft takes a very, very long time to wear down. These were done in the moly. They're done in the molybdenum disulfide. In particular, because the molybdenum disulfide is very good as a dry film, which means when you do start it up and it's cold and you rev it up, it doesn't want to bond to the cylinder. It doesn't want to stick to the oily and the carbon deposits, so it will move when the other valves will want to stick. The other advantage to it is mollies dissipate heat really well. So a power valve gets a lot of abuse because you have exhaust gas going through this hole or across this notch. And in a good running motor, that should be 1200 to 1250 degrees Fahrenheit. Aluminum melts around, depending on the alloy, in the 1100, 1200 degree neighborhood. But again, it depends on the alloy and a lot of other factors. But so the exhaust gas that's running across these is pretty close to the melting point of the material itself. That doesn't mean the material gets that hot. The exhaust goes across them and the heat's quickly dissipated out into the water jacket and the cylinder bores. However, being coated with molybdenum disulfide helps those valves dissipate that heat back to the cylinder, down to the shaft, and up to the pin bore at the top much more effectively. So rather than the heat all being concentrated in this area, the heat travels down here and the heat travels up there because the molybdenum helps dissipate the heat better. So dry film properties, less wear and tear, better heat dissipation. We offer all of our power valves with this coating if the customer wants it. We also offer the same power valves with a ceramic coating. The ceramic coating is more expensive, but it is going to last longer. It is not a heat dissipator, it is a thermal barrier. And what that means is that where these take the heat from the center of the valves and move it out to the outsides and help put it back into the water jacket and other parts of the cylinder, when you ceramic coat something, it stops the heat from being absorbed into the aluminum. And the idea is the heat passes all the way through it and never gets into the power valve. The reality is, moly coated power valves, ceramic coated power valves, they're going to make the same amount of horsepower. There's really not going to be any difference. Moly coated power valves are going to be better when the customer doesn't warm up the bike or bike or quad after it's been sitting for a period of time, because they don't allow the oil and the carbon to bond very well to them, and therefore they're able to rotate. Even if there's some carbon buildup, they're able to rotate around and not get in a bind. The ceramic coatings are going to have way better wear properties on the gear because the ceramics just don't wear. And because they are thermal barriers, they are not going to allow the heat to get into the body of the valve as well. So the temperature of the valve itself will be less internally, and there'll be essentially less heat cycling within the material. So again, the ceramic probably is the better in a running application that is high heat, high RPM, and a lot of wear and tear. The moly coating is less expensive coating, and it's better to prevent the valve from sticking. However, it doesn't give you quite as good a wear property on the gear teeth, and you will pass more heat through the valve itself. Couple of different ways to tackle a similar problem. In the end, you can go both ways. They both have some minor advantage and disadvantages, but a coated valve will probably last about 3 times as long as an uncoated valve. Doesn't matter whether you ceramic it or moly it, at least 3 times as long. Like I said, I've never seen a ceramic valve come back. I can't tell you what it takes to wear out a ceramic valve because we've been running them for more than 10 years in motors that go to the dunes every single year, multiple times for 3-day weekends, 5-day weeks, week-long trips, and they just don't wear out. I can tell you that they don't break and they don't wear out like the factory ones did. So, bottom line, if you need to buy power valves, those are the best power valves you're going to buy. They come from Joel Little. You can find Joel Little on Facebook. If you're on any of the forums, the Facebook pages, I'm sure there's other places to get hold of Joel. But if you want a pair of power valves that are going to be reasonably priced, because the factory power valves are so rare, you will pay considerably more money for a factory power valve than you will for a set of Joel's power valves. Um, but in my opinion, they are the best power valves that anybody's ever made for a Tecate 4. Got to thank Joel. He put a lot of effort into it. I know it wasn't easy. He spent a lot of money on them. Anybody who knows anything about machining knows you pay a ton of money for the design. They have to be designed in 3D. There's a lot of, while it looks like a pretty simple part, it's pretty technical because where these teeth are in relation to this notch is everything. You can't just cut a notch and then put teeth anywhere you want. The edge of those teeth have to be exactly in proportion to where the edge of the valve is. And the fact that Joel even took the time to put the indexing notches back in those two teeth so that you could use the factory timing marks. It really just, it's that level of effort, and recognition that, yeah, you don't have to have those two marks on there. That's an extra machining operation that probably cost, I don't know, $10 to do. Hard to say for sure, but $5, $10, whatever, to put those in. But it makes all the difference in the world when you put the motor together, because you literally put the rack gear in, you put the marks where they belong, you line those two marks up, your valves are timed, and they're timed right every time. So, again, big thanks to Joel. He put a lot of effort into these. If you need power valves, I would highly recommend you contact Joel Little. If you can't get hold of Joel Little, you can contact us at ilrperformance.com or ILR Performance or Dave Roberts on Facebook, and we will put you in contact with Joel Little. Cool power valves, good job. Hopefully that kind of gave you a little bit of an overview of the pros and cons of the power valves and the pitfalls that have been out there for a lot of years. And you will see in the next Tecate 4 build video that we're going to put out tomorrow. You will see how we install these billet power valves, and you will see how we time those billet power valves, and it's pretty sweet. They work pretty well. Anyway, so thought I'd build a power valve video. It's kind of an overlooked thing, but it does make all the difference in the world. If a power valve breaks, you have to pull a cylinder off. So if you can buy a power valve that doesn't break and a power valve that services you well, you can go years and years without ever having to pull the cylinder off the motor. If your motor's running poorly, pull the pipe off and check the power valves. If the power valves are broken, don't ride it anymore, because you're going to do some damage. It's going to cost you a lot of money when you destroy that cylinder or you tear up the governor assembly. But if you get to that point, you got to replace power valves. Those are the power valves to buy. Anyway, thanks for watching. Would greatly appreciate it if you would subscribe to the channel and like the videos. It doesn't cost anything to subscribe. When you subscribe, you can get notification when we put out new videos. And subscription is what Facebook looks at for content. I don't get paid for any of these videos. I don't make any money to do this. It's something that I do because I think it's important to put information out. However, it does help my business overall, and potentially, if I get to the point where my subscribers are large enough, I could possibly get some compensation from YouTube. If I'm working in the shop, I'm making money. If I'm making videos today, I don't make any money. So subscribing, liking the content, that tells me that people are watching the videos. It tells me that people want me to make more videos. That's cool. I don't mind doing it. If you watch the videos, please take the time, just click the subscribe button, like the videos that you like, If there's comments, if you got questions, whatever, I try to answer the comments as soon as I can. I read every single comment and I respond to every comment that needs a response. If somebody sends me a comment that says, cool, I really love it, uh, I may not respond to that because that's cool. I love it. But I will respond if you have a question, if you have a comment that needs a response. I respond to everything. So appreciate your support. Anyway, thanks for watching. Talk to you later. Bye.